our example number 1, which is the design of N type of truss or N type of foot over bridge. Okay, so students, in the last lecture, we will discuss about how to forces acting on top chord, and after calculating the forces on top chord, in the next slide, we are discussing about the design of top chord. And you all know that the design of top chord is as the compression member. Okay, so the design of compression member is already studied in your semester number 6, which is ESD, Elementary Structural Design. Okay, so now we are moving further to our next step, which is your step number 9. So your step number 9 is forces on bottom chord. Okay, so all the funda are remain same as discussed in the last lectures that. Okay, so first of all, in the last lecture we will discuss about forces on top chord. So for top chord, your first member is U0 U1, and the maximum force of U0 U1 member is acting on an opposite span. Okay, so U0 U1's opposite end is L0 L1. Now from U0 U1, one diagonal member is U0 L1, and this diagonal member is acting at point L1. Okay, so this is the reason why for our first member our force of top chord is maximum on L1. Okay, so similar funda is represented over here for the design of bottom chord, and first of all forces on bottom chord. Okay, so your forces of bottom chord in which your first member is L0 L1. Now L0 L1's opposite end is U0 U1, and from L0 L1 one diagonal member is L1 U0. Now U0 is your opposite end. Now from U0 your left hand side distance is 0 and your right hand side distance is 24. Okay, now you all know that whenever we have to find out influence line diagram, what is the equation? So equation is A into L minus A divided by L into H, in which the value of A is 0 in this case, because from U0 your left distance is 0. Okay, so if we are putting the value of A is equal to 0 in this equation, then our influence line diagram of member L0 L1 is 0. Now your second member is L1 L2. Now your L1 L2's opposite end is U1 U2. Now you can see that one diagonal member is U1 L2. So for second span your diagonal member is acting on this point. Okay, so for this point your distance A is 3 meter and L minus A, which is equal to 21 meter. Okay, so students, after putting all this value we will get our answer of second span is 0.875. Now it is already discussed in the last lecture that your top chord is always in compression in through type of truss, and your bottom chord is always in tension in through type of truss. Okay, now this bottom chord is in tension member, so there is two types of influence line diagram is draw in this step. So you can see that in the first type we are draw our influence line diagram on upper side, but this is important. negative sign. Negative sign indicates the tensile force. And in second method, you have to draw your influence line diagram on lower side. Okay, so this is the two methods. Now your third member is L2, L3 and same funda remain for L2, L3 and L3, L4. Okay, so students, this is your four influence line diagram. After finding out influence line diagram, your next step is to find out forces on bottom chord. Now, what is the equation of forces of bottom chord? So the equation is area of influence line diagram into total UDL. Now, area of influence line diagram, it means your first member is L0, L1. So for L0, L1, your influence line diagram area is 0 because for first member, your influence line diagram is a straight line. Okay. So for first member, your influence line diagram is 0. So your member of first member is 0. Your second member is PL1, L2. Now you can see that your influence line diagram having the shape of triangle. So what is the area of triangle? It is 1/2 base altitude. Now this is 1/2 base means 24 meter and altitude means 0.875 into total UDL. So this total UDL will be find out from our step number 5, in which we have to find out separate dead load, separate live load, and after that we have to combine total dead load plus live load, because it is already discussed that there are two members, first one is vertical and second one is diagonal, having some portion in tension and another portion is in compression. So whenever we have to design for vertical member and diagonal member, at that time we have to calculate separate dead load and separate live load. But for a top chord and for bottom chord, we have to use the summation of all this value, which is the factor dead load plus factor live load. Okay, so it is 26.6. So after putting all this value, our answer of PL1 L2 is 279.3 kilonewton. Now your third member is PL2 L3 and the equation is area of influence line diagram, which is 1/2 base altitude into total UDL, which is equal to 26.6. So students, after putting all this value, we will get our answer 478.8 kilonewton. And your last member is PL3L4. So for PL3L4, your answer is 598.5 kilonewton. Now you all know that there are four forces. First one is 0, second one is 279, third one is 478 and last one is 598. Now you all know that if we are designing any member for maximum force, then it is compulsory to pass that member for lower values. Okay, so now we are not designing all the members as per its load, but we are designing a member for maximum force. So you can see that our maximum force is 598.5 kilonewton. Now the design of bottom chord is as per tensile member. So this tensile member is the revision of your elementary structural design, in which there is chapter number 4, design of tension member. So you have to refer page number 32 and 33 of IS 800 2007, in which you have to find out three values: design strength due to yielding of cross section, design strength due to rupture, and at last it is design strength due to block shear. And in block shear there is two values, TDB1 and TDB2, and the smaller value of TDB1 and TDB2 is considered as your third final answer. Now, if you have three answers, then the smallest value of these three is your final design answer. Okay, so let us revise what we are doing in this step. Generally, this step is covered in your next lecture, but in let us revise. So, first of all, your design force is 598.5. So, with the help of yielding of cross section, we are choosing one ISA, Indian Standard Angle, and you all know that if we are choosing two ISA back to back in our top code member, then it is compulsory to choose two ISA, two number of Indian Standard Angle back to back for bottom code only. Okay, so in this step we are choosing the Indian Standard Angle based on maximum force, and after choosing that Indian Standard Angle we are try whether our selected section is pass or fail in all these three values. Okay, if your three values, from your three values, any one of your values is less than design tensile force, then you have to redesign your section. Okay, so students, this step will be discussed in our next lecture. Thank you.